test. Very good. Yeah, okay. We'll create the grid lines, I mean, yeah. Yeah, Manish bhai. Yeah, Manish bhai. We'll create the grid lines. Okay. See, I don't want to what do you call, give you the information about the grid lines. You all know that grid lines, it is a mode of like communication between the consultant and contractors, right? Actually. Another thing is, setting out of the columns. Correct, yeah. Okay. So these two purposes, and one more thing, the grid lines usually it comes from the structure, not from architecture. Okay, it usually comes from the structure. Architecture, they don't need grid lines. Whatsoever the structural drawings, a structural peoples will create the grid lines. They will, as it is, they will copy paste. So they don't create any grid lines, because the grid lines usually it passes like vertical elements, either columns or shear wall. Actually, they don't need any grid lines for the block walls or anything. Actually. Okay, so wherever our columns is there, and they will just superimpose our columns and our core walls into the architectural drawing, and they will just start copying the same grid line to the architecture. This is what, and they will make it as XREF. Okay. Okay. So now what I'm going to do, so I'll just create the grid lines. Okay, build like as it is to be passing in the center of the vertical elements. Okay. Yeah. Okay. Can you see, keeping the cursor in the left corner, it's showing 0, 0 here. The coordinates is here. The coordinates is here. X, Y, Z. X, Y, Z. If I'm keeping cursor in the left side corner, X0, Y0. Okay. So that is the origin point. Okay. That is the origin point. So what I'm going to do, I'm going to measure the dimension, but I'm not going to keep the dimension as it is. Say, there is an option called draw dimension line. Okay. You can drag it and you can pick it up to keep it permanently. Actually, if you don't want, you can just measure it as it is. Say, for an example, I'm starting from here. So I need a grid lines from here. Actually. So 2.2, the distance. Someone can write down? No, actually. Okay. I'll just start from Y direction. Yeah. Whenever you're starting the grid lines like this, you just note down the dimension. Then it's easy for you. And you won't do any mistakes. These are all like, it's not about the mistakes. It saves time, because you can edit any momentum. It's not a big deal out of it. Even if you made a wrong dimension, you can edit it. But it will save time, actually, because I wouldn't prefer you to spend time on this modeling kind of things. Okay. So first point, actually, in Y direction, I'm going in Y direction. Yeah. Starting with 0. The first coordinate is 0. The second one is, 2.2. And the third one is actually 4.4. Then 6.9. Then Yeah, fantastic. 13.525. 525. Yeah, here directly. 20.15. This is y direction. This is y direction. I'll go from the x direction. Draw dimension line from here. 8, which is 0, starting from 0. X direction starting from 0. 8, then 10.5, then 18, then 20.8, then 23.6, then 31.1, 31.1, then 33.6, then 41.6. Yeah. Okay. Okay. Now what I'm going to do, I'm going to create the grid lines. Go to edit. There is an option called edit. And there is an option called edit stories and grid systems. Same option, the one which you have used for the stories, right? Number of stories and the height adjustment, master story, whatever you did in the same option, there is an option called modify show grid system. Is it screen is visible? Is okay, right? You want me to move the board? No need, right? Modify show grid system. Yeah. Fantastic. Now I'll call it as actually, say for an example, X direction is A, B, C, D, and Y direction is numerical letter 1, 2, 3. Yeah. Okay. So X direction, I will call it as A, B. You can keep on add, and you can edit the dimension. Yeah. I'll show you again. Edit stories and grid system. Can you see? Yeah. Then modify show grid system. Okay. And this, you can directly start entering the, what do you call, grid lines and dimension. If you want to add further, there is an add button is there. You can keep on add. Yeah. I'll call it as A again. 0 first. B is actually, you need to tell me the dimension. I didn't note down. 2 points, sir. 8. Then this is X direction. Yeah. 8. Then 10.5. 18. 20.8. Fantastic. 23.6. 31.1. 33.6. 41.6. Yeah, fantastic. And again, in the y direction, I will call it as what? 1, 2, 3. Yeah. Yeah. What is second one? 2.2, I believe. Then 4.4. Then 6.9. Yeah. 13.525. 20.1. Fantastic. Here, there is a bubble size is there. Can you see bubble size? Okay. This is the grid bubble. You can reduce it actually if you want. I'll reduce little bit. It's up to you because it's not been overlapped. Yeah. Then the bubble will not be overlapped. The bubble in the sense grid idea. Can you see here? There are two options. Is there? I don't want to confuse you, but since I mean, like just wanted to know here. Just a minute. Here, can you see here? There is display grid data as ordinates, display grid data as spacing. The one which we took it from ordinates 0, 8, 10.8. So from the originate we measured everything, right? From 0. If you don't want from 0 to 4 meters, then again you can start with 4 meters to 6. So it's a spacing image. You get a point. Either you use this, either you use this. But I wouldn't prefer this because then again you have to take it one by one. You get a point. This is very easy. Start from 0, then you measure it. Actually. That's all. And grid color, if you want, you can change it. But these are all like, yeah, the y will be what do you call positive. Yeah, positive. The x will be positive. If you go backward, it is a minus. If you go backward in the x, it is a minus. That is the reason I used to always say start with 0 point in the leftmost corner. Keep it. Because those 0 0 point, keep it in the CAD itself. It's very easy. Like, putting the UCS icon, you can put it 0 0 because the UCS icon is 0 0. You paste it, actually, it's very easy. It's not mandatory. You can keep it anywhere, even 1 meter, 1.5 meters. What happened actually while creating the grid lines, you will face a problem. Actually. While measuring some dimension, you will face problems because then always you have to use the calculator. Actually, a -2, -5, -3, something like. If you keep it 0, it is easy. These are all like, some modeling tips and to save your time. That's all. There won't be any kind of mandate. You have to go with this. The reason why I'm telling actually, I'm a such person actually, I'm not going to give you the importance of the modeling. The modeling you just give very least importance. But you have to do proper modeling. It's not that actually. If someone will ask, sir, least important, and modeling will be like, even if it is not connected, no to no. Modeling the sense, give in a proper way, okay. But don't give you as an importance like an architect. Okay, looking at 3D actually, again, like, the structural people, 20% actually will pop up with the architecture. Ah, nice 3D, nice slabs, and the column will like no, these are all like, then you've been like, changing your path. Don't give you such kind of things. I mean, yeah, the moment when you click okay, automatically actually it will be like, pop up all those things. See, if you feel the bubble size is small, you can still go for it. I wouldn't like, it's up to you, huh? If you feel bubble size is small, you can change it or you can even increase it. Huh? I just kept the same, 1250. Huh? For me, because for you, you need to see the screen. That's the reason I increased. Huh? Can you see here? There are two columns actually, which is not in the grid lines. Okay, so you need to edit this as well. Even I didn't notice this. Yeah, yeah, fantastic. Even this column also, I don't know whose model it is. Someone who did the model actually, this column is not even center line actually. Yeah, okay. I'll tell you in an easy way to make it in a central line actually. Okay, but you need to be with me. Okay, so what I'm going to do, I will measure this. Draw, yeah. How much is this? It's not center, huh? It's not even center, huh? Leave it. Okay. Yeah, see, if you want actually, like, you have to select this. But the problem is actually while selecting, you need to make sure because this column is continuing from base to till roof. If you select from here, it will select only one floor. Okay, then what you have to do, make always clear selection. Huh? Whenever you are not sure about if you have selected anything like, other than this, first make sure it is a clear selection, nothing is selected. Then change one story to all story. One story to all story. Then if you edit anything, if you move, then it will be like, impact to the all the story. Okay. Now I selected this. So I'll go to edit. Then you can go to like, move joints, frame cells. So how much you need to move, you can give the dimension. This is to move. Huh? Okay. Not like CAD, but here it is bit of command. Huh? Select this, edit. There's an option called move joints here. Huh? Yeah, the distance actually you can measure it as it is the same grid lines. Draw dimension line. Okay. Say from here, something like this. Okay. Okay. I don't know whose model. Huh? अभी फिलहाल के लिए छोड़ दो actually. It's fine. Huh? फिलहाल के लिए छोड़ दो. We'll create the grid lines for this, no problem. We'll create C dash or F dash. Yeah, C dash, F dash. And later, no issues. Now leave it as it is. But it's clear, right? What you have to do. Huh? Yeah, what you have to do. Huh? Just try to understand the concept. Huh? What you have to do, where to do actually. Huh? Just try to understand the concept. Huh? That's more important. Huh? Don't by heart it actually. Okay. That is the reason why in the beginning of ETABS class actually I wrote it like in a simply supported beam. To do the manual calculation for simply supported beam, what are the steps which is required actually. So go with the same steps. Don't by heart the ETABS. Huh? Because today you will use the ETABS. After 2 years, 3 years, actually there is some other softwares will come. But the principle will be same. Only interface will be different. You're getting a point. Use any software, but the principle will be same. Section sizes, modeling, loads, load combination. Definitely instead of loads, actually there won't be anything else. Loads only. Load combination, load combination. Yeah. This is only tool. Okay, so don't buy heart this. Yes, of course. I mean, where the options are there, you need to know. Okay, that's more important. But you will get to know. If you 2 times, if you practice actually, automatically you will get to know easily where the options are. Okay, so it's not so hard, like to find out that option. ये किसका मॉडल है पता नहीं. Okay, I'll adjust little bit, no problem. Okay, सही है. 0.105 difference is there. No, but the problem is wall also it is inclined actually. It's perfect now, then fine. Give me. I'll use this. Give me. Oh, use pirka madira. Use pirka. Le. Does anybody want to use his model? I think it would be perfect. You will understand. Okay. Lock பண்ணீங்கன்னா டெலிட் பண்ண முடியாது. லாக் வீடு லாக் ஆயிடும், மேக்னேஷன் லாக் ஆயிடும். இந்த போயிட்டு இந்த இதை கிளிக் பண்ணீங்கன்னா நீங்க செலக்ட் பண்ணி வெயிட் பண்ணிக்கலாம். அதுவும் அவ்வளோதான் முடிச்சு. அப்புறம் இந்த ஸ்டோரி மட்டும் தான் இருக்காமா. இப்போ பார்ட்ஸ் வச்சுக்கிட்டீங்களா, நீங்க டெலிட் பண்ணீங்கன்னா மொத்த ஸ்டோரி இருக்காது. வச்சுட்டு என்ன பண்ணுவோம், அவ்வளோ கஷ்டப்படுறாங்க. என்ன ஃபைல் நேம் சார் நீங்க கேட்டது? ஓகே, இதானா சார் அல்ஜிப்ரா ETABS மாடல்? इसमें चाहिए ले लो. यूज करो मॉडल क्लोज होगा. ओके, then you go to grid line system, you just create the grid line, 2 more grid lines passing the model. Either if you want C dash, or you just create the continuous number actually. But note on the further ரொம்ப க்ளோஸா இருக்கும்போது கொஞ்சம் டைம் கொஞ்சம் க்ளோஸா இருக்குல்ல க்ளோஸா இருக்கும் ரொம்ப ஈஸியா இருக்கும் A-dash, B-dash. ஏன்னா முதல்ல ஸ்கூல் கிரேட் தான் you need to change it there. அதுக்கு A-dash, B-dash, C-dash. You don't need to. இது யார் மாடல் ஆக்சுவலி அலி மாடலா ஓகே அதனாலதான் சொல்றது ஆக்சுவலி உங்களோட அந்த 50% ஒர்க்க கேட்லயே வச்சிருங்க டு அட்ஜஸ்ட் த லைன் டு அட்ஜஸ்ட் த சென்டர் லைன் ஆக்சுவலி DX வச்சு நான் அதான் உங்களுக்கு I'll take the class separately. I'll take it actually. CADல இருந்து DXF கன்வெர்ட் பண்றது தான் I'll give you. I'll give you. நான் சொல்றேன் உங்களோட ஒர்க் 50% அதுல வச்சிட்டீங்கன்னா சேவ் டைம்.
Sir, could you please share this file, the one which you're using now?
They're going to share in the WhatsApp. I think your voice is very low. Just a second.
Yes, sir.
Can you speak little loudly?
Yeah, could you please share this ETABS file, this latest one?
Someone is like, what do you call, sending in the group.
Okay.
You already shared, Mr. Karthik has already shared in the group. இது ஓகேமா இந்த மாடல் பர்ஃபெக்டா இருக்கு ஆக்சுவலி இந்த ரெண்டு கிரிட் லைன் மட்டும் ஆட் பண்ணி விட்டுருங்க பட் யாராவது ஹெல்ப் பண்ணணும் ஆக்சுவலி இந்த பபுள் சைஸ் வேணா இன்க்ரீஸ் பண்ணி விட்டுருங்க ஓகே 1000 ஓகே உங்களுக்கு தெரிஞ்சுனா ஓகே ஃபார் யூ டு ஸ்கிரீன் நீட் டு பி விசிபிள் so I will increase more little more yeah for you it's okay here go to option graphic preferences you can increase the text font size it was 6 actually then I'm going to change it for me I'm changing 10 it's up to you because screen is written for that's the reason I'm just giving okay யாராவது எனக்கு ஹெல்ப் பண்ணுங்களா ஆக்சுவலி இந்த கிரிட் லைன் சூப்பர் சார் 16.5 எது சார் ஆக்சுவலி சில இருந்து ஷி டேஷ் ஷி டேஷ் 16.5 10க்கு பதிலா நான் ஆட் பண்றேன் எப்படி வேணா பண்ணலாம் நோ இஷ்யூஸ் ஆக்சுவலி பட் நீங்க எடிட் பண்ணாலும் ஆட் பண்ணாலும் மறுபடியும் ஆட் பண்ணணும் ஓகே நீங்க இப்போ இன்க்ளூட் பண்ணிருக்க மாட்டீங்க பாருங்களேன் இப்போ நீங்க டைரக்டா ஆட் பண்ணீங்கன்னா இது லாஸ்ட்ல போய் உட்காரும் ஓகே அப்படியா இதுலயா ஃபென்டாஸ்டிக் ஷீ டேஷ் தென் ஓகே வெரி குட் ஓகே 25 ஓகே ஆட்டோமேட்டிக் உட்காந்துருதா வெரி குட் ஓகே Area, okay. But it's showing, right? She doesn't have dash. Okay. No problem. Model nalla perfect target. Very good. This is what the difference, you know. I think he's ETABS நீங்க இப்பதான் யூஸ் பண்றீங்களா அது ரொம்ப வருஷமா first see he was using the ETABS actually frequently daily Ali Ali this is what the difference, this is what the difference is, you know. The one who is using like you know, new he has just one who is using frequently he used. So CAD का प्रॉब्लम है, CAD में थोड़ा ऊपर नीचे है। हाँ हाँ okay, okay. Yeah, okay. So, boss, what I'm going to do, Rohit, he asked me something. Actually. What I'll do, I'll go to F18, floor number 18. Actually. Yeah, okay. But whoever it you kept all story, change it immediately one story. Yeah? Okay, don't forget to keep it all story. Yeah? Because still to get familiarized. Huh? If you familiarize, then it's fine, no problem. You know, like, you know, what you're doing. You're getting a point. At least, like, you know, you need to finish one or two models by independently. Then what happens? You know where you are. Either one story or all story, similar story. ये confusion चला जाएगा। अब प्रॉब्लम क्या होएगा? तुम all story में रह के कुछ भी edit करेगा, delete करेगा ना, वो पूरा किया। Actually, you wouldn't know. Then you will keep on like you know continuing the model. Once you come to the analysis, then only you. Then how many times you will redo? You cannot. There is only like you know limitation will be there. 4 5 times till you save the last times. No problem होएगा. Okay, we'll add the planted columns. Huh? Okay, one story raklo. I'm going to delete this. What do you call? Yeah, we will not delete actually. We will not delete. What I will do, I will take it as like you know this portion. Can you look at it? Only this. The grid D to F. Yeah, grid D to F actually. I will take it exactly the same rectangular portion to the upstairs, which is upper roof. Yeah, in an easy way. So what I'll do, I will add the columns here. I will add the columns here. Yeah. Then I will add the columns here. I will add the columns here. Okay. So what you have to do now, edit, edit stories and grid system. इसमें जाके modify roof में जाके. Okay. I'll go very slowly. Edit, edit stories and grid system. Okay. Quick add story. Yeah. Yeah. Quick add story. Then go and edit this quick add story will be upper roof. Huh? Yeah, na? Keep the same height if you want. Huh? No issues. If you want to change it, change it. Okay. So what I'll do, use this arrow marker. Come right below to the roof. Select this roof. By whenever you are selecting, make sure clear selection is hidden. Huh? Whenever you are selecting it. This is also to get familiarized. Huh? एक बार तुम familiarize हो जाएगा ना, automatically your eyes will go there. Huh? You don't need to do this. This is make a practice. Huh? Because we used to do such kind of mistakes in the beginning actually. क्या होएगा? Time जारी होएगा. Like you know. Yeah, roof you select actually. Then edit. I'll copy the roof to upper roof. Huh? Then I will delete over there. Yeah. Completely, completely. Edit, replicate, story, select only upper roof. Huh? Then okay. Then go to the upper roof by using arrow mark. इधर तो यही नहीं. Something is happening here. Okay, yeah. Display undeformed shape कर दो इधर display undeformed shape to come out from the command. To come out from the command. Is it okay? You got it like this, right? Yeah, you got it right. What I'm going to do, I'll delete the slabs. I will delete this entire portion. I will delete this entire portion actually. Okay. Yeah. Even I'll delete this, like, what do you call all those things. Create new columns like 300 by 600. Yeah. New columns like, 300 by 600 or 300 by 800, whatsoever it is. Create the column 300 by 800 actually. Section properties. You know how to create the columns, right? Section properties, frame section, use any column, add copy of property. Yeah. It's okay, right? Add copy of property, then give to C2, 300 by 600. Oh, no. Hold on. Because that is a circular column, right? Then it will go to circular column. You want to create the circular column, create it, or else add new property. Add new property. Then here rectangular is there, right? Click the rectangular. C3, 300 by 600. (300 by 600). Modify, show modifiers. Yeah. Okay. Modify, show rebar. Make sure column is selected. Then your grade of, then clear cover. That's it. Overdone. Use this icon. Can you see? 1, 2, 3, 4, 5. Fifth icon. Use this fifth icon to place your column. C3. Yeah, see, my column is like this, in a horizontal direction, right? If you want to rotate it, here. If you want to rotate it, there is an angle here, right? Change it to 90 degree. Not only 90, 30, 45, whatsoever it is actually, it will be automatically there. इधर डाल दो, इधर डाल दो, इधर डाल दो, इधर डाल दो. सही है ना भाई? डाल के बीम डाल के कनेक्ट करके छोड़ो. You have only one beam, create another beam. Section properties, frame section में जाके 300 by 600 का बीम क्रिएट कर दो. हाँ, but while creating the beam, make sure depth and width you have been, like, putting properly. That's very important. Then connect from here to here. Who are finished, then draw the slabs as well. Yeah. Uh, for here especially, HDL, minimum HDL, you need to mention 3 kilonewton per square meter, including waterproofing and everything. Yeah. Waterproofing, foam, concrete, everything. Minimum HDL as per authority is 3 kilo. Live load you can go for 2 or 1.5 to 2, doesn't matter actually, but go for 2. Actually 1.5. Accessible roof is 1.5, but no one is going for 1.5. Go for 2. No problem. assign shell load uniform SDL 3. Then assign shell load uniform live load will be 2. That's all. If you're keeping in what do you call in 3D, there is a portion here. Okay, there's a portion here. These 4 columns are planted, huh? Yeah, in the slabs, right? But not all. 2 columns are planting in the beams, 2 columns in the slabs. The external 2 columns are in the beams, huh? If the slab are different, if the slab edges is different edge. So while taking the DXF, you can take multiple DXF. No problem. But make sure origin is same. That's all. If the origin is same, you can take. That's right, yeah. Okay. The planter column is okay. Yeah. Yeah, because it's called it as headroom only, no? Headroom only, right? Huh? Two different colors actually. Now it is gray color, right? There it moves like little darker gray. So definitely warnings will create it actually. The analysis actually, you will not get the what do you call result in difference, to be honest. Because it's a minor gravity load difference, no? 240 mm slab thickness multiplied by 25. It's a minor gravity load. इतना gravity load में difference नहीं दिखाएगा. But the problem क्या आएगा? Warnings आएगा. Okay. Even doesn't matter actually. Okay. That's not a big deal out of it, but. SDL only including combo roof, 3 kilometer. Na? Two. Actually, 1.5 is enough for accessible roof, but you can keep it 2. When you 1.5, actually DM will sometimes to say no, increase it actually. See, gravity load people won't give you much importance when this 0.5, 1 and all actually, because your vertical element is so strong to take care of the gravity. The only problem where you do have actually lateral force, wind and seismic. In buildings, you will have only two problems. Okay. The majority is actually your sway, and the second one is shear problems. Mostly you will have a shear problems. Okay. How you are going to tackle it shear? That is a mostly you will have a shear problems. Shear failure in columns, shear failure in beams. Mostly. Vertical, actually, I don't think so you'll have mostly. Because the columns are strong enough to take care of the vertical actually. But because of the lateral and additional moment will be created and you will have a problem in the vertical edge. Not due to gravity load, you will have a problem. Yeah. Okay. What I'm going to do, so define, there is an option called P delta options. Huh? Yeah. P delta options. P delta, I've already told you, right? Actually. So when the structures, if you don't have any consideration of lateral force, then there won't be any sway. There won't be any sway. But the moment when there is a lateral force, actually, the structure will undergo for sway. But your load will be remain same. But fortunately, the load is here, but the load has been moved to the eccentricity. With this eccentricity, additional moment will be created. So those will be catered by P delta analysis. So P delta, it is required when you do have a lateral force. When you are applying the lateral, when you don't have any lateral force actually, but obviously you do have a lateral force. I'm not talking about the seismic, wind also lateral force. Very important. P delta concept is what? When you do have a lateral force. Any buildings, yeah, even structures as well, industrial structure as well, whatsoever it is. If you do have a lateral force, structure will sway. If you don't have lateral force structure, you don't have any sway. As it is. Okay. Okay. We'll go for
From where did we take
iterative.
this P delta? Can we show again?
यार हमारा मनीष भाई ये ऑनलाइन का जो वॉइस है ना वो इट इज वेरी लो है एक्चुअली इधर भी इंक्रीज कर दिया आप इंक्रीज वो अबू जी कुछ पूछ रहा है शायद
Yes, sir. Can you hear me now?
Yeah, I can hear, but your voice is just a second. We'll increase the what do you call? Voice कम जा रही है उनको? Can you able to hear my voice, right?
Yeah, I can hear you well.
Okay. उसका voice ही थोड़ा कम है. उसका कम है. उनका सेटअप सही नहीं है. हाँ. Okay. आपको यहाँ से वॉल्यूम अप है. चलो. Okay. Yeah, okay. So assume this is the frames, right? Assume there is a frame actually. So what am I going to do? What am I going to do? Okay. So I have a load on top of it, right? I have a load on top of it, right? This is only a gravity load. So with the gravity load, I mean, the structure will never sway. What is sway actually? The structure which has been like, is going from original place to as a displaced location. This is the sway. You're getting a point. Yeah. This is the sway. Yeah. This is the sway. Okay. What happened? This gravity load, this gravity load, it goes here, isn't it? Yeah, if it is sway. Okay. When it goes, I mean, when you do have, what do you call, when you do have lateral force, either it could be wind or seismic. Wind idhar aayega, seismic idhar aayega. Right? Seismic is going to come below ground. Wind is going to come actually along the face of the structure, right? Any kind of lateral load comes, I mean, the structure which is going to be like, undergone for sway. So in this case, what is going to be happen? Your gravity load actually, which also is going to be like, displaced to the different location. So the CG of the original location to the CG of the displaced location, which is going to be cause additional eccentricity. Okay. Then this P multiplied by eccentricity, you will get what? You will get additional moment. You getting what I'm trying to say? Yeah. Okay. And this goes here. Okay. The distance between this is called eccentricity. Okay. Then this is called P. P. Then moment equal to P into E. Say na? Okay. But remember, P delta analysis only you can use it when you do have a lateral force. Okay. This is an additional secondary effect of moment. Additional secondary effect of moment. So go to define. There is an option called P delta options. Yeah. Iterative, dead load, 1.2 factor of safety, then add it to SDL, 1.2, then live load will be 1.6. Okay. What was it? Nothing. What was it? Yeah. Okay. Tolerance, there is no tolerance. No tolerance. 0.0001 is nothing but no tolerance. Okay. That's all. Go to define. Go to design. Concrete frame design. View revise preferences. Make sure the code is ACA 31819 as selected. Design, concrete frame design, view revise preferences. Okay. Then go to again design, shear wall design, view revise preferences. Make sure the code has been ACA 31819 has been set. Automatically all kind of parameters will be selected actually. Yeah? Okay. Now what you have to do, concrete frame design, view revise preferences. Okay, just a second. Huh? Okay. The design, concrete frame design, view revise preferences, right? Change your steel grade actually. If it is not steel here, go to design, shear wall design, view revise preferences, change your grade of steel. Yeah. And if you scroll down, there is utilization ratio factor will be 0.95. Yeah? This is by default, it will be 0.95. If you want to change it one, change it one. Doesn't matter. But sometimes, like, the authority engineer actually will try to, like, this is nowhere in the code. Huh? Okay. The code says it's only one. Okay. Still, if you want, you can change it. But depends on the authority engineer actually. They'll ask us to, like, this will help you because if it has been fail in the 5%, then it won't fail. You're getting a point. What I'm trying to say, because now you are limiting 95%. You are only using the capacity of the structural element only 95%. You are not using 100%. You are keeping 5% cushion. You don't need. Okay, first of all, you need to understand. Don't afraid. Huh? You have a material factors. You have a load combination on top of factor of safety. On top of it, you don't need anything. Factor of safety. People are thinking like, I'm keeping like, bit of conservative. No, there's no conservative design. Your design like, over design. Knowingly, you're doing the over design. Because you do have many factors. Huh? The 500 MPa, what you're trying to say in steel, actually, it is not 500. It is more than that. Much more than that. And on top of it, you do have factor of safety. The load combination. You're not even designing for service combination. All you're designing by ultimate combination completely. So don't keep any factor of safety on top of it. Actually. Yeah. You change the support condition, right? To the, yeah, interesting. Yeah, okay. Okay. Yeah, go to design, concrete frame design. Yeah, leave it. Go to define load combination, define load combination, add default design combos. I wouldn't suggest this. I wouldn't suggest this. Actually, you need to enter manual combination. All the combination you need to enter manually. All ultimate. The one which I gave you as per the code, right? AC716. So whatever the combination is there, you need to enter. I will show you how to, like, create the set of two combination, but you need to create it. I wouldn't suggest this. The reason why, this is not part of modeling. This is part of design, the one which you're going to do. You need to understand the either it could be vertical elements or beams. Is it failing under which combination? तभी design करने का, like, मजा है. Then there is no pointing out of design. Then you're relying on some softwares. Software will do everything actually. Then your importance will not be there. Then you will not keep your importance. Your importance is zero. If you want to keep your importance actually, then you need to know the structural elements is failing under which combination. Sometimes you can bypass, that's, that actually. But I'll tell you how to bypass actually. Okay. To reduce the torsional modifiers and kind of things actually. By giving the external modifiers actually. How to make it safe, how to make it pass. Which are the things which authorities are accepting actually. And those kind of things. But you need to know first actually. It's not that actually if I've given slightly those, what do you call, the stiffness modifier reduction actually, then you will not get to know. What you will do, any beams will reduce actually, you will use this, like, stiffness. It's wrong. Actually, okay. Now, time being, like, I'll show you, like, two combination, how to create it, but you can just, go for add default design. So add new combination. As per the American code, ACA 31819 actually. You have to use it for the crack section. You need to reduce the, what do you call, moment of inertia of the section sizes. You cannot use 100% at all. You cannot use 100%. ULS 1, yeah, ULS 1, dead load 1.4. Then you can add further SDL also 1.4. Huh? Then you can add it. Huh? So like this, you have to keep on add for ULS 2, ULS 3, ULS 6. I will add one more combination. Add copy of combination. ULS 2, 1.2, 1.2. Yeah, 1.6. This is how you need to add the combination. Yeah. For time being, what I'm going to do, add default design combos, concrete frame design. This you have to use it after selecting your code. If the code is not selected properly, say for an example, if it is an Indian code, then all the combination will pick from Indian code, because the library, it is there as inbuilt. All the combos will be there with relevant to the codes. If you're using like Chinese code, it will take only Chinese combination. Okay. Convert to user combination editable. Don't forget to select, because if you want to edit this combination, you can edit anytime. Okay. Then okay. Add default design combos. Concrete frame design. Okay. Anything is concrete frame, right? Even shear wall also, it's a concrete frame. Column beams also concrete frame. So automatically, the moment when you have selected the code ACI 31890, so it picks from the internal library of all the combination according to ACI. Instead of ACI, if you would have choose like Indian code or any other code, actually, it picks the combination according to the code. So make sure the code is selected first, then go for this combination. A concrete frame design, convert to user combination editable. Okay. Add new combo. I just shown you like how to add. Add default design combos. That's it. Then concrete frame design. Click CC. Add default design combos. Concrete frame design. Then convert to user combination. Then click OK. That's all. Then automatically combination will be generated. But to be honest, I wouldn't prefer this. Though it is by default. And one more thing, don't think that actually you need to, what do you call, retype once you have created set of combinations. Say for an example, you have 25 combination. Once you have created set of combination of 25, so for all the project, do we need to create? You don't need. You can keep as a master file, this master file. Delete this model. Okay. Bring any DXF. All the section sizes, all the materials, all the load cases, all the load combination, everything will be there. So you don't need to spend of this 1 hour, 1.5 hours, what you've been like, spend to create all those things. You don't. So what you can do in master file, you can feed as much as section sizes, starting from 200 to 600 to 200 to 800, 300 to 600 to 300 to 800, 400 to, what I'm trying to say, you can keep like, then when you're being like, fine tune the model, whichever the section sizes which you haven't used, delete, send it. But keep master file. You can all that also. But what I'm trying to say actually, like, the combination you're asking, right? Actually, properties I haven't tried in the Excel actually. Combination we have done that, but properties I haven't tried. Let me see. Yeah, but combination I'm sure. Combination you can do it. Excel tool. Here itself, you can take it to Excel. You can type all those things. You can bring back from Excel. Because we usually use when you do have like envelope combination. Envelope, you need to add all the set of combination, correct? All the, but don't add envelope combination for altimeter. It's wrong, huh? Yeah. If you want to add the envelope combination only for servicer, but don't add for envelope combination for altimeter. What it does actually, maybe like in gravity, actually, it shows gravity force is more. In lateral moment is more actually. Okay. Then it gives like a worst case, it will pick the gravity, it picks the moment actually, it will design your structure. That's completely like, you're doing over design. So what you're going to do, don't create the envelope for ultimate. If you want to create the envelope only for serviceability. Serviceability,
Sir,
it is
could
only
you
to
please
check
repeat
the
the
model.
envelope one more time, please?
Time period,
Envelope.
deflection, displacement, and drift actually. Now I'm talking about envelope combination. Envelope combination is what actually? Among you're going to add like, all the combination, you're going to find the, what do you call, the worst combination to get your results, right actually? Or the combination which is going to be governed to the structure. You cannot say only the lateral force combination is going to govern for all the columns, right? Maybe lateral force combination is going to govern only for the external columns. Internal columns, there won't be lateral force. Might be only gravity is going to be covered. You're getting a point actually. But what it does actually, when you create the envelope, so envelope is what? Define, load combination, add new combination. I'll change from linear to envelope. Okay. Then what I'll do, ULS1, ULS2, I will add it, keep on. Okay. Among this 50 combination, it will pick the worst combination, agreed. But what it does actually, it won't pick only the combination alone. It will pick the maximum forces P, maximum forces M of some other combination, maximum torsional shear from some other combination, it will design it actually. Then for sure your structure or your vertical elements will fail. Even if you don't do that, ETABS will do the envelope, but it automatically like, only to take only the combination. Out of 50 combination, whichever it has been worst actually, it will take only the combination. It will never take like, PM shear like this. You getting a point actually, what I'm trying to say. But if you want to create the service combination, say for an example, I'm going to create service 1. Okay. Serviceability, there is no factor of safety, right? Okay. So SDL. Okay. 2. Right, yeah. What I'll do, now I'll create the serviceability, because serviceability, I don't do the design actually. I will only check for what you call serviceability case. The deflection, displacement, drift actually. But still it is more actually. I agreed actually. But it won't fail. It won't affect it. We are getting a point actually. Might be 15%, 20% will be literally more. That is the reason I told you, like, what you call, we are not going to check the serviceability for this model. This model is called cracked model. Why it is called cracked model? Because you already apply the stiffness modifier by reduced the moment of inertia. We are going to use the serviceability model actually, keeping all as one actually. The serviceability model using the 100% of moment of inertia. This model is only for the crack. This model is only for the design. This model is only for the analysis to extract the forces. This I'm not going to check for the serviceability case. But we used to do, when we are checking this model serviceability case, 100% sure it will be safe for the serviceability model, because you already increase your moment of inertia. By reduction of 30%, you are going to increase like, using 100% of moment of inertia. Definitely it will pass, because 30% difference will be there in the column. You're getting a point actually. We used to check, instead of like, creating the, again, like, moment of inertia changing actually, what we do, we will check the drift, displacement, what do you call, deflection, time period, everything. If it is safe here, then I don't need to create any separate mode. But if it is fail here, then I will create like changing the modifier, then I will check it. If you do have only 25 to 30% difference, if it is more than 30%, definitely it is fail. 30% is straightforward, because your vertical elements, you reduce 30%, right? Actually, the same 30% will have an impact, because your structural lateral stability system is by vertical elements, not by the slabs, not by the beams. Actually. The pure vertical elements, either it could be columns, or it's shear wall, or it is the combos. It is a dual system. Either it is called building frame system, or it is called shear wall system, or it is a dual system. Only 3 systems you do have it. On top of it, whatever you are adding, like, bracing and kind of things, this is to control your drift actually. This is either you can call it as outrigger, but it is not outrigger. Outrigger is what actually in any corresponding floor. Usually we used to go for mechanical floor actually. We are going to introduce like, what you call the floor to floor deep beams actually and cross bracing. That is called outrigger, purposefully to control your drift, not for displacement. Don't confuse yourself actually. Displacement you have on top. If you just, put a beam on top floor or further, like, 2 floor down actually, to have like, surrounding beams actually, your displacement will be controlled because your maximum displacement will be on top. Drift is not like that actually. Drift, it could be 2/3, drift, it could be 3/4 actually. Okay. So if you want to control, if I provided the beam on top of it, actually, it will not be helpful because from 2/3 onwards, might be drift will continue for 5 floors actually, then it get gradually reduced. But if it is a slender building actually, from 2/3 onwards, the drift will be like, maximum, it will go till top because the building is slender. It will never be back. The same drift will be like, followed. It's like a cloth. You're taking a cloth, you're just holding it actually. If you're doing like, fold, the bend will be like, 2/3. If you're holding a cloth actually, imagine if you're holding a cloth on 2 hands actually. You do like, fold from your hand actually. When you do fold, okay, the bend will be like, happen only 2/3 or 3/4. Okay, that is the bend which I'm talking about. That is a drift. Because why I'm just, telling you to hold the down actually. This is what will happen because the seismic is going to come in below base. But wind is straightforward. Wind, it is going to be act on the face of the structure. 100% sure actually you will have the displacement on top. Nowhere there is chance of displacement. It is like, at mid or 2/3 or 3/4. You're getting a point actually. The people are like, only misunderstanding the concept actually. Being like, by hearting the things. If you catch the concept actually, then everything will be clear. You're getting a point actually. If we do have a problem in the drift actually, no one is going to check on top. They will check from which floor onwards I do have a problem. From which floor onwards. Because you need to know, even if you're providing outrigger, actually, from which floor I need to start with outrigger. It is not that actually, sir, I provided the outrigger on top roof or upper roof. I provided some bracing actually. 100% sure you will not controlling drift actually. Then you have been like, understanding the concept in a wrong way. Actually. You have a problem in the drift actually. Okay. From some floors, either 2/3 or 3/4. I mean, from who you cannot sure about actually this drift is not going to be continued till top. If it is a slender, 100% sure it will continue. If it is like, square or rectangular, even like, bit of irregular shape, no problem actually. But it goes like this. It's like, award lady we used to call. Okay. The bulb will be created only like, certain portion. 3, 4 floors, 5 floors. Actually. There you can just, put an additional bracing or outrigger. You're getting a point to control it. But what I can tell you, the biggest advantage actually, okay, yes, outrigger is important. I mean, okay, I'm not talking about like, when a fond of outrigger. To reduce the drift actually, okay, to reduce the drift actually, try to keep your hand in the where the moment of inertia is more, where the stiffness is more, only in the core wall. The lack of stiffness, the building is like, what do you call actually? Oscillating, right? The drift is what? Because of lack of stiffness, right? If you're increasing my stiffness, then it will be controlled. Okay. So the stiffness, either I can increase number of columns, that is not going to be possible, right? It is impossible. You can add like, number of columns. No. You can add the beams. No, it is not possible because people are like, going for a flat slab. The only possibility is where actually, where the core wall staircase is there by increasing 25 millimeters, 50 millimeters, 75. So these are all like, to increase your mass stiffness from down to top. Huge stiffness. From base till to top actually. Imagine the moment of inertia. If you're multiplying the moment of inertia with the height actually, you'll get the huge stiffness. Rather than you're talking about like, 400 by 800, 400 by 1000 columns. It's a frame elements. You will get the moment of inertia, but when compared to the core wall, it is this. Because length of core walls. That is the reason sometimes you look the high-rise building actually, the wall thickness itself, the core wall especially, shear wall, it goes 500, 600, 700, 800 actually. These are all things to control the drift especially. Yeah. And sometimes this also people used to do. I model the beams here, right? Okay. Instead of beams, actually, I will model the wall. Then I will leave the opening. Then the wall, will give you like, bit more stiffness than the beam element, because beam is called frame. Both are same. Okay. Usually spandrel beam, actually, we used to go this or this. This for an easy way of modeling. If it is pass, it is okay. If it is not, then I'll go for modeling. The wall with the opening, 2.1. Then it is going to be like, treat as wall. No. I will change those portion as a spandrel beam. How? Say for an example, I'll select this wall, assign, shell. There is an option called what actually spandrel label. The moment when I give you spandrel label, it won't design as a wall, it will design as a beam. Even this wall, if I select this, if I give you spandrel label, what it does actually, it will not give you vertical, horizontal reinforcement. It will give you top and bottom. Top steel, bottom steel, and shear. Same like a beam. How the beam you are going to get the results actually. Top steel, bottom steel, and shear reinforcement. The same way which you are going to take it. Say for an example, I do have a precast wall actually. In precast, actually two options, right? One is load bearing structure, another one is non-load bearing. So most of the load bearing wall actually 70-30. 70% is what I mean. It looks like a wall. It looks like a wall, 120 millimeter, 150 millimeter, 160, 200 actually. Actually, 70% it is not a wall. When you just check the detailing actually, it goes top bar and bottom bar. And this vertical, it is called like, links. It's a deep beam. It's full height deep beam. That is the reason whenever the precast structure, when you want to have any kind of like, opening, when it has been executed, when it is casted, actually, people will never go for it. People will just check the drawing, whether they have designed as a beam or whether they have designed as a wall. If it is wall, it's fine. You can open it. But if it is a beam, actually, then you're directly cutting the bottom rebar. You're directly cutting them. So many precast building has been collapsed in DIP area. There was one Gujarati who built your own, he is a developer, okay, who has so many buildings. They used to go for all precast structures. Okay. So what they thought actually it is a wall. Then they started breaking, like, changing from 1 bedroom to 2 bedroom, from 2 bedroom to 1 bedroom, studio to 1 bedroom. Like, they opened the partition actually. And they did blunder mistake as well actually. And there are like, non-load bearing wall, there are load bearing wall. The hollow core slab actually will never rest on like, what we call non-load bearing wall. Will rest on only load bearing wall. Actually. And you will have a cushion from load bearing wall to hollow core slab, like, 30 millimeters, 40 millimeters, 25 millimeter will cushion. Because in order not to transfer those load to the non-load bearing, the sealant which we used to keep it actually, the purpose is what I mean, will not transfer those load to the non-load bearing. That is the reason we used to keep this cushion. 30. Will never touch this non-load bearing wall direct to the hollow core. If you're touching, then you're changing the behavior. Then the portion of the load which goes like, to the non-load bearing wall as well. Okay. So what happened, like, he been like, whatsoever he want, actually he did it. Because it's internal, nobody is going to notice. Of course, so DM inspector, until otherwise, actually, if it comes any sound, anything, like, if anything, like, observed, then he will come and check. If it is not, actually, nobody is going to come and check it. The whole floor, actually, for entire half floor has been collapsed. He did so many things. He got the moment when he demolished, then you will find the rebar, actually, 25 millimeter bottom. Can you imagine 4 rebar of 25 millimeter at bottom of wall? Who will put? And it's a deep beam. If it is wall, then I will have only 12 millimeters or 16 millimeter vertical. The majority of the reinforcement will be vertical. And like, what you call horizontal shear will be like, less 8 or 10, something like 25 millimeter, 4 bars it is. And they thought, no, this is additional reinforcement. Demolished. Hollow core slab actually has sagged. And half of the floor actually, half of the, what do you call, the floor itself, it has gone. And the DM has got like, huge fine on them. Especially precast, I mean, you should be more careful. I mean, when it is executed, you need to read the drawing, which is like, load bearing and non-load bearing, whenever they used to ask the opening, especially. Even for hollow core slab, people used to do further openings actually, okay. You can cut 2 strands. You can cut 2 strands. What is the width of the hollow core? 1.2 meter constant. 1.2 is standard actually. And if you want, you can customize it. 60, 70, okay. But more than 1.2, I don't know, I'm not sure about it actually. But 1.2, their mold is constant. Out of 1.2, actually, you can cut 2 strands. 2 strands. More than that, also it has a problem. They have a cushion on it. Even they themselves, they will say 2 strands, you can go for it. Yeah, okay. So where we are actually, we added the load combination, fantastic, yeah. Yeah. You go here, analyze, set load case to run, set load case to run, change if errors or warnings, actually change only if errors. Only if errors. Huh? The small warnings, actually, then you can just ignore it. Huh? Only if errors. Huh? Okay. Yeah?
Sir, why did we set this load case to run? What was the requirement?
The load case to run, actually, in the sense, I mean, if there is any small kind of warnings when you do have not proper connectivity, actually small kind of things, actually you can ignore it. What I'm trying to say, else you need to spend time actually to read all those warnings actually to correct it. Small things, actually you can just eliminate. Then what happens, there won't be any kind of warnings will be there. But if there are errors, major mistakes, what you does, actually directly it shows, okay, all those errors. But don't remove this. Okay,
Okay.
just start running the model. Run analysis. Yeah, सही है ना भाई? रन एनालिसिस कर दो. The model has run, right? Fantastic. So go to display and deform shape. Display and deform shape. Yeah. Yeah. Can you see here? It's called show deformed shape, right? Yeah. My cursor. Yeah. Show deformed shape. And click what do you call mode. Mode. The first mode, actually. First mode. Automatically it selected the first mode. Click OK. Can you see here? It shows the time period 2.51 seconds. Yeah. Okay. Keep the 3D model, actually. And you start animation. Can you see there is an animation here? Start animation. This is X direction. The one which is going X direction. The first mode is X direction. Yeah. And if you go to second mode, actually, change it to second mode. And this is called Y direction. This is called Y direction. So who wants to take a break? Take a break. What do you call? Right click. இது உங்க மாடல்ல அது இல்ல மாறி இருக்குல்ல ஓகே நான் காமிக்கிறேன் சார். இந்த செட் கிரிட் சிஸ்டம் விசிபிலிட்டி இருக்கு, அதை கிளிக் பண்ணிட்டீங்கன்னா ஓகே. தென் அகைன் மறுபடியும் கிளிக் பண்ணீங்கன்னா மறுபடியும் செட் கிரிட் சிஸ்டம் விசிபிலிட்டி. The screen itself right click. Here, screen itself right click, set grid system visibility. If you want to just hide the entire yeah, okay, fantastic. So what we will do now, we'll check the what do you call displacement and as well as what do you call drift as well. Correct? Yeah. Okay. So go to display, show table. Yeah. Joint output. Then there is an option called displacement. Just expand it. Don't select anything. You don't need to select anything. Just expand it. I will tell you what to select. Yeah. And there is an option called joint displacement. Can you see here joint displacement? Just select the joint displacement only. Only the joint displacement. Then go to the select load patterns. We will select only the window. Only the window. And select load patterns here. Select load cases, only window. Select combos, clear all. Because we are not going to select any combos. Actually, the wind combination is what? The wind combination. 1 times of radius, 0.5 times of radius, 0.7 times of wind. In order to check the displacement, you can use this combination. Because when you are checking the wind, the 100% of your self-control structure will be. Okay. You cannot take like 100% of light load, already told you. Okay. So the code is giving only the privilege for about 50%. If you take 100%, it is much more safe. Then you cannot allow. The code is not allowed, only 50%. And in this combination, you don't need to take like 100% LBD, you can take only 40%. But what we are checking actually, we are checking only this and this. Then we ignore this, then ignore this. But you can create the set of combinations. Okay. The wind displacement check one, WD1, WD2. In this actually you can add it. So this is for one WD1. The next time, second combination WL2, WL2, WL2. So like this you will have a whole combination. Very important. If it fails when you are checking the displacement. But 100% sure the structure will never fail in the displacement until the structure is very tall. Maybe you are talking about like 70 story, 80 story, 100 story. Then the seismic will not down, then the wind will dominate the DC. If you are talking about 30, 35, 40 stories, seismic will down. But if you are talking about more than that, 70, 80, 85, then, but even the shape of the structure also matters. The shape of the structure is like a square, a rectangle. Again, my reference, I will change the number. But if it is slender, actually, then the wind will dominate. Okay, wind will dominate than this. But you cannot say, you have to check both. Huh? Okay, this is I'm just only giving the example in a face of experience. But you have to check both. Huh? You have to check displacement, you have to check drift pitch. I'm just giving like, only for the sake of reference, when it is going to dominate, when the wind will move, when the seismic will move. Okay, just for your knowledge. Huh? Okay, clear all, huh? Clear all. Okay, okay. Yeah. Yeah, I'll repeat it again. Huh? So display, show tables here. Huh? Joint output expand, displacement also, we just expand it. Huh? Then select only the joint displacement. Joint displacement. Load pattern, only the window, not for the dead load, only the window. Select load cases, only the window. Yeah. And select combos, clear all. You're not going to select any combination. Yes, you need to select the combination. When it is fails, you can create this combination, you can select it. Then okay. Yeah. You can take it to the X. Yeah. Clear all, clear all, clear all. Drift is what actually in the original shape is going to displace shape. And whatever the displaced position as it is, I'm going to check with the allowing. If it is not satisfactory, but this is going to come back. Going to come back. The building is the if you want, did I show you? Can you see the whole building actually? Literally, you can see movement. Huh? Can you notify this? Okay. Can you notify this? Yeah. This is after getting slowed down. Huh? After getting slowed. Actually 9.1 magnitude. But this is not 9.1. Huh? This is after getting slowed down actually. Little bit actually. So it automatically getting slowed down. But the first most thing actually it goes. Immediately actually. It goes. Okay. So from the original position, If it is goes to the front, if it is come back to the original position, whatever the seconds which. This is might be like 1.2 seconds, something like 1.5, 1.2. 1 second is this, right? Actually. Not this is animation. This is animation. I don't think that this is animation. Yeah, this is animation. Yeah, okay. Clear video of this. I have. I will share you the clear video. Okay, yeah, fantastic. Okay. Now, what I'm going to do. So display, we did it right actually. Yeah. So okay. Then file, export current table to Excel. You can take it to the Excel. You can take it to the Excel. So automatically those table actually, it will be shown in the Excel sheet. Yeah. Okay. The building which, if it is under displacement, which direction it goes, either X or Y, right? Actually, there won't be any kind of Y. Yeah? Okay. So what you do from UZ to these are all rotation. Delete it. I don't want you to confuse you. Delete it. Only you do have X and Y. Yeah. Yeah. The tabs, file, export current table to Excel. Automatically the Excel will open. Now you filter it. The bus, you filter it. Data and filter. Filter it. From here, UX. Which one? Yeah. What is the maximum you're getting? H by 450 to 500. The allowable displacement. H by 450. The H which is measured from ground floor, not including the DC. Then it is used to RX completely. Then select everything. Make it filter. Data. This called largest to smallest. The automata. Largest to smallest. It shows maximum to small. But you need to check both the direction. Okay. But you will get one of the direction is less actually. Less to stick with that. Where the stiffness is more, actually, you will get less. You getting more. In UY, actually, you will get less, right? Because all the walls in the longer axis, correct? Yeah? All the core wall in the longer axis. You can see. Yeah, can you see here? How many stiffness you do have? Like here. 1, 2, 3, 4, 5, 6, 7. Huh? All the walls. In the shorter axis, actually, you will have like small wall. Huh? Also, it matters actually. What you're getting displacement. H by 450 to 500. This H is in terms of millimeter. Because what you're getting is millimeter. What you're getting the external sheet is mm. If you can see on top, it shows mm. In Excel, actually, you can see on top, it shows mm. But when we enter the formula, convert it to feet and it will be pure displacement. Because I didn't check the block. I got to check the displacement first and then go for it. So they asked me this million dollars. I don't want to confuse. This is for displacement. Don't relate to it. Yes, definitely related to time period. Then in this case, you need to enter the entire data, not from the ground floor. Yeah, because time period is related to. Yeah, because same thing is going to occur the below the foundation. The displacement is only taken from ground floor. How many basements is there? You should not know. Even 4, 5 basement actually, because basement doesn't move anything. Then if you're taking, you underestimate. Right now, you're taking a full height, and you are you're putting a more value, more margin. That's all. Now, basement will never have any impact. The base static structure from ground page. Even sometimes ground floor also half of ground floor say buried half units. Assume because of the ground undulation, ground changes, topography. Maybe like 1 meter you are buried, 2 meters only. Then you need to go only 2 meters on this. You should not take anything which is buried below ground. Freezing. Clearly freezing. Cantilever. But don't ask me cantilever is H by 82. This is 24. H by 452 is 24. It's a little stringent. Okay. Stringent. H by 450 to 500. H by 450 to 500. In this H, you can put it as M because you are taking as M. The value what you are getting is M. So you can put it as M. Okay. You can put it meter as we convert it into no problem. Let's see, to avoid confusion, what I will do, I will give you the SI unit formula for the time period SI unit. Then forget about that. There's only one factor you need to multiply. If you are having confusion for the putting feet, then I will give you SI unit formula. Okay. Everyone is familiar with this CHN power of 3 before. No one asks actually, they don't, what they call, if you don't remember the factors, they will remember the CHN power of 3. It should be less than this. 100% it has to be less than this. What you are getting is its actual displacement. The actual displacement, it has to be less than H by 450 to 500. It has to. If it is not safe, what you will do? Say, assume it is not safe. Assume it is failed. What you will do? Now, to understand in a better way, I'll show you the tabular column. Where you are getting the maximum displacement. Can you see here? Largest to smallest. 34.31, right? Okay. Come down, upper roof 34, roof 33, and again 1730. Okay. 18 you are getting like 25. 33 to 25 comes. Okay. Go to what do you call? 16. We already filtered. That's the reason it shows like this. If you don't filter, say for an example, I haven't filtered. Okay. Yeah. I haven't filtered. We already filtered. Okay. I haven't filtered. Now roof. Now roof, these are all roof. Over 18 le punch, 18 le 24 aiche. Then go to what do you call 17. I'll go here. 17, 16, 15, 14, 13. Khalas, okay. How much? 17, 16 is only 18, 19 millimeters. Then go down. 15, again 16. Definitely for sure, right? If anything wrong here, then your model is wrong. This is the best way. Anything wrong here, if you're getting maximum displacement somewhere in the middle, you have a connectivity problem 100%. That's the reason I told you to understand the concept. Displacement, it has to be more on top. It has to be at any cost. If anything here, you have a connectivity problem. When column is not connected, beam is not connected, it's going. What happened actually? Then it goes something fishy over there. Okay. Kya karoge? Again, coming back to the question, if it is more actually, what you will do? Proof what you will do? If there is no beam, you can add the beams actually, or you can increase the beam with another 100 millimeters, 200 millimeters. Because you are getting more right actually. Once you controlled over there, that's it actually. You don't need to control right below. Only top roof, if you controlled, and if you're putting beam on top roof, actually, no one is going to have an objection. Even you can put on an inverted beam. If there is an objection, actually, take this beam as an inverted, that's it. Then this beam can act as a parapet as well. Displacement is not total height. From yeah, but you need to take from ground floor. Which is 14 cent. Displacement में problem नहीं है. Displacement में क्या है? Displacement actually is directly controlled by. Yeah, displacement is directly controlled by your self-weight of structure. When the mass is more actually, when the mass is more actually, then where it goes? You will have a problem in the drift. Displacement, you will have a problem for sure, 100%. When you do have a building like, in business bay, slender building, width कम रहेगा, length ज़्यादा रहेगा, then lack of stiffness. Problem क्या है? Stiffness and weight. It required mass, right? Actually, okay. If you do have sufficient mass, it is okay. If you don't have it, actually, definitely you will have a problem. Good display, show table, expand the joint output, expand the displacement. Don't select anything. Select the story drift. Select the story drift. First, kind request, try to understand the concept. Rather than getting the numbers, actually, try to understand the concept. If the concept is very strong, actually, 200% guarantee that any kind of structure you can do. See, now here we are not talking about like, sir, I've spent like 15, 20 years in the construction field. Say for an example, like managing the site activities. No one is going to ask you to change the field, but this additional information, additional knowledge which you're going to acquire, it will, I'm sure actually it helps you everywhere. When you're having an argument, when you're having discussion, actually. And Abu Jain was telling like, he's been more stronger than his project consultant. Now this could happen, right? So don't think that like, all the consultant engineers are like, super duper. It may happen actually. What 50% of people think when the consultant, he knows, they knows everything. Who's it? Yeah, story drift. Then go to select load patterns. Select seismic, only seismic, EQX, EQY. Then go to select load cases. Again, seismic. Then combos, clear all. Okay. Same, similar way. Load pattern seismic. Load cases also seismic. And the combos, Clear all, huh? And okay, huh? Yeah. And take file to export to the Excel. Similar option. Huh? Take it to the Excel. Huh? Fantastic. Huh? Yeah, we'll remove the labels XYZ. These are all coordinates. Huh? Remove this. Huh? I don't want you to confuse. Huh? Labels. Keep it only drift. Huh? Only drift. Huh? Then what you do? Then do the filter. Huh? Al-Islam. The reason why you are doing filter actually, you can segregate EQ, EQ, yeah? Okay. So you can easily compare what is the maximum in each place, what is the maximum. And this thing is what you know. So you will come to know what you call where is the maximum. Now I'll show you where is the maximum. You will get to know easily. See, EQX. What I'm going to do, I will only select actually EQX now. Yeah, EQX. Here, what is the CD value? Here, going here. Define load patterns, seismic, modify. CD value is how much? 4, right? Yeah? Okay, fantastic. So now here, 4 multiplied by, yeah, this is actually, I supposed to give you like, the codal reference. The problem is actually in code is 4.5. Okay, we had up till now, the problem is, they want us to consider as building frame system. Even it is like, it's a combination systems are there. They want us to consider. When there is a shear wall is there, they are asking us to take 5. It's fine actually, 5 for shear wall system. Huh? Because in high-rise building, actually, if you see, most of the walls is shear. But in our case, it is a combination. Column also is there, wall also is there. Actually. But if you do have like, completely shear wall, actually, you can take it as 5. Okay, what I'll do, in between, like, the weekdays, I will give you the reference for interstory drift. I will give you the reference for the stiffness modifier. I'll give you the reference for displacement. I'll give you the reference for load combination. I'll give you the reference for what do you call time period formula for SI unit actually. Okay. Then I'll give you the reference for what you asked. The R value, CD value, amplification factors. Actually. These are all. But who note down actually? You send me in the WhatsApp. These are all value. I will give you all the evidence. The codal pages. ஆறுல சொன்னா displacement stiffness modifier stiffness modifier displacement allowable displacement oda evidence allowable actual drift oda evidence allowable drift oda evidence yeah 4 then what is here load combination 5 then time period 6 yeah what is here और कुछ है भाई R value, CD value. These are all take it 7. Not 6. 7 comes. Very good. 7 I will give you. But you need to send me in the WhatsApp. Yeah. Yeah, send me the WhatsApp actually. Yeah. So what I'm going to do, see, this is delta x divided by 1, right? This is in meter, huh? Then multiply by, sorry, yeah, multiply by 1000 millimeter, 4.276. But take it as like, take it, take it actually largest to smallest. Yeah, first largest to smallest. Can you see where it is largest? F10, F11, F9 actually, and slowly is getting reduced. So it means what? 9, 10 level. How many story you do have? 16 story, right? Yeah, it's almost 3/4. What you are getting is 3/4. Okay, you don't understand, right? Okay, what I'll do? Okay, can you see here? अभी क्या करेंगे? इधर ही कर देता हूँ. CD 4 multiplied by this value divided by 1, right? Importance factors, huh? Then multiply by 1000. दो bracket डालो, 4.276, huh? Okay, खलास. Okay, these are the values, huh? अभी इसको थोड़ा देखो ना. Upper roof is 4.2, huh? Yeah. Roof is 4.5. तो नीचे आओ, नीचे आओ. Slowly is getting increased, huh? I'm just giving like understanding of displacement and drift actually. Slowly is getting increased actually. Come down 4.8. Come down, it is increasing actually. Come down. So maximum is starting like almost 9th floor onwards, huh? 6 millimeters, right? 9th floor to somewhere here 5.7, 5.8, almost 13th floor actually. अब समझ में आया आपको मैं क्या बोल रहा हूँ? समझ में आया ना? Okay. Now here you need to understand two things. Forget about the number. The number will be reminded. Forget about the number. What? CD multiplied by delta x divided by importance factor. Multiply by 1000. You need to understand. मुझे समझ में आया मैं आपको समझा नहीं मैं बोल रहा हूँ फिर मत Yeah. value. Okay. Divided by divided by 1. Okay. Multiply by this is that. That's the rate number. Okay. So you are minus square rectangle, but you see the difference. When you know another difference, you will never get just the maximum of the top. Update here on the 8, 9, 8, 10, 8, 11. Here and almost 2, 3, 3, 4, 0. May have 4 reduce on. EQI similar. Important. And you say now because see the problem importance factor is what actually. I'll tell you something. Yeah. See, you can form and understand one question. When you're designing hospital building, importance factor is 1.1. When you're designing like military building actually, it is 1.2. So this difference. When you're designing only residential building, commercial building, office building, it is all 1. When you're designing like other than other building, then you need to take import. Other than the exact form person. Then what will happen is you become practice. You have the core of children, you will never forget. So for you it is not important. For you now the importance is what? Where you are getting more? What exactly the equation means? Okay, where you are getting more. And the more filter point short panama, filter point where you check control. Otherwise there is no way. Value. Almost 7 actually. And the story height is 0.02 multiplied by the corresponding story height. All the story height actually is 3.6. Allowable height. இதுக்கு நான் சொன்னேன் அந்த நீங்க நோட் பண்ணல எனக்கு கொடுக்குறீங்க நான் உங்களுக்கு எவிடன்ஸ் கொடுக்குறேன் எல்லாத்துக்கும் போட தனித்தனியா கொடுக்கும் then you can keep it the model எதுவும் பிரச்சனை 0.005 100%. Yes, check one. What you are getting 0.0016. 0.0016 here. But my every model of question for it's never given. Maximum. So these are all that what you're getting with symptoms. That your model is correct. What you have to do again, you need to spend half an hour time to check your model. Anyway, no problem. You need to move the behavior. And the rotation container deformation. Other than one termination. Okay, India connectivity is not India or you rotate the partner India. Height. No, right. Because this is interstory. What you're checking is interstory. Overflow, not the overrun. Overflow, interstory. ஒரு 9th floor 10th floor mechanical floor load ஒரு 10th floor will add a huge load or 15 kilometers per square meter water tank. Okay, say for example chiller phase அது ஒரு 15 kilometers மொத்த mechanical floor 15 kilometers per square meter live load ரன் பண்ணி நான் பார்த்துட்டு உங்களுக்கு என்ன பிரச்சனை எங்க yeah, okay, right, yeah. Now the pending is what? Torsional irregularity check. Okay, then we'll go for what actually? The column design, beam design and wall design actually. Okay, column design, beam design, wall design actually, what do you call? I'll give you the things which you can keep it here. I think I'm supposed to have this. சொல்லுங்க சார் இது சார் இதுல இருந்து ஓகே என்ன பண்ணுங்க இந்த மாடல் அப்படியே saves this model, huh? Yeah, we'll check it now itself. Yeah, உங்க மாடல் பெர்ஃபெக்ட்டா இல்லையா போய் பார்த்துடலாம். Yeah, give different name, huh? Basement 1 தவிர basement 1 the slab just apply the new 1 kilometer per square meter SDL 1 kilometer live load is huge. Okay, I'll tell you. Select stories, huh? There also, but here actually you will select, you will delete the even the plan also, the one which you created plan, no? That's also will be deleted. Stories, I will delete everything, huh? From basement 1 till top, huh? Select close, then delete from the keyboard, huh? We'll have only this, huh? Yeah, grid on the off பண்ணி விட்டுருங்க. Yeah, right click, set grid system visibility, huh? select stories, select from basement 1 to till top. Yeah, select, close. In keyboard, delete it actually. Yeah. Okay. Now, what I'm going to apply the load, assign, shell load, uniform, SDL, 1. Yeah, only 1. That's it, right? Yeah, model run பண்ணி விட்டுருங்க. That's all. Yeah. Yeah. We are doing this actually. He made a correct point. Why we are doing? Why we are doing this? Why we are doing this? எதுக்கு இது பண்றோம் கார்த்திக் இது? Why we are doing this? Why we are doing this? பக்கத்துல உட்கார்ந்து அவர்தான் அந்த கொஸ்டின் ரைஸ் பண்ணாரு, சப்போர்ட்டா கரெக்ட் பண்றீங்க. To check the model whether it is like no proper or not. How do you check? How do you check? With respect to influence line diagram, okay, this is the forces which is going to be governed to the columns, right? The base columns. What you're calculating the manual ILD diagram, it has to be same in the model, right? Then I can say the model is 100% correct. Okay. Reason why it is 1, you can apply 2, 3, no problem. Then influence area multiply by 2. Instead of that, I can take only influence area. Because it is only 1, right? If you multiply 1, then same influence area. Then that is influence area is nothing but load. Influence area multiply by the load, you get the actual load. If it is 1, it's the same influence area load. Okay. No, here. 3D model. Okay. Display undeformed shape. Yeah. Display force. அப்படி parallel பண்ணுங்க நான் சொல்றேன். Force system. The model is locked. You know that. The model is locked actually. It is ready for to extract the result. It is ready for to produce the result. You cannot edit. You can edit only the load cases and load combination. You can edit the load combination. Still, the model is locked. Other than that, you cannot do it. What happened actually? You can keep on editing. There won't be any kind of software use. Importance. After I'll tell you, analyze the model. Apply பண்ணிட்டீங்களா SDL 1 kN per square meter. இங்க click பண்ணுங்க. Slabல click பண்ணிட்டு assign shell load SDL போயிட்டு 1 kN per square meter. Yeah. Apply பண்ணிட்டு then analyze the model, then go to display, force, support reactions. Yeah. SDL, only SDL. Tabulated. Okay. இப்போ நீங்க பிளான்ல கூட வச்சுக்கோங்க. Tabulate பண்ணீங்கன்னா I think you can keep it in the plan. Doesn't matter, I think so. It has to show. No, wait a second. After applying the load, run the model. Okay, I'll give you another what do you call easiest way. Go to display. Yeah. force stress diagram, frame, pier, spandrel link forces, right? Here, select the axial force, huh? SDL. Case on the SDL, huh? Then select the axial force. Here. Fill diagrams. Show values, huh? I need the show values, huh? Then only the values will show up. If we don't select, the values will not show. Only the contour diagram will come up. Okay. How much it comes? 53.43, right? Take it column half, column half, column half, column half. Take this include. Measure it from the ETABS itself. So, display. So, deform the shape. Display. Closing. Frame. Shape is given.